Here we go with the last set of questions. These questions are going to be a little trickier than the ones that we did before, but they are still going to be dealing with what happens when we have repetition. So in this example, how many arrangements of the word puppies can be made under each of the following conditions? So firstly, without restrictions. You may want to try and pause this question right now and try it by yourself before you see me do it, because this one you should be able to do after watching the third video. So puppies has a total of 1, 2, 3, 4, 5, 6, 7 letters. However, puppies has 1, 2, 3 p's, so I must divide by 3 factorial to get the total number of words, because those 3 p's are identical and won't give me a different word if I change the arrangement of the p's. Okay, this next question is a little bit different. What if each arrangement has to begin with a P? So let's give spot 1 a P here, and then U, P, P, I, oopsies, U, P, P, I, E, S. So here's the rest of the spots for the letters in puppies. Now, this first P here is fixed. So what I can do is just consider the rest of this word. So basically, I'm going to consider the letters in uppies. So uppies has 1, 2, 3, 4, 5, 6 letters. And now I only have the 2 p's that are repeating. So my total number of arrangements is just 6 factorial over 2 factorial. Since this first p here I've basically taken out of the equation. I don't know why journal keeps doing these big lines. It's very frustrating. Okay, let's try the next one, or pause it and try it by yourself before watching. So what if the first 2 letters are both p's? 2, 3, 4, 5, 6, 7. So what if it starts with PP and then the rest of the letters? U, P, I, E, S. So if I fix these 2 first p's, then I'm just dealing with these letters right here. So that gives me 5 factorial. And now I have no letters repeating, and so that's it, 5 factorial. What if all the p's must be together? Well, let's see. P, 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 U, I, E, S. So if all the p's must be together, they don't necessarily, the question doesn't say that they must be first in the word, but they must travel together. So this goes back to one of those questions that we were doing a couple videos ago, where these 3 p's are going to travel together as one blob. So if they are traveling together, I have 1, 2, 3, 4, 5 objects to arrange, so 5 factorial. And then I need to zoom in and see how many different ways are there of arranging these 3 p's. Now there's a couple ways of thinking about it. The first way of thinking about it is looking at it and saying, well, if I change the order of these p's, nothing changes. So there's only one way of having the 3 p's together. So that's if you really understand what you're doing. If you want a way that's going to work every time, you can look at it and say, well, I need to multiply it by the number of ways that these p's can be arranged. I have 3 p's, or 3 letters, and then divide by the number of letters that are the same. So 3 p's must divide by 3 factorial. So you'll notice that when you do this, you end up essentially multiplying by 1 and it not changing your final answer. So there's different ways of thinking about it. It will still get you to the same answer. This way, although redundant for this question, is useful in that it will allow you to interpret multiple kinds of questions. For example, if this wasn't just 3 p's in a row, maybe it was 2 p's and 1 r, then this would be 3 factorial over 2 factorial since there would only be 2 p's repeating. So this way would be useful for other questions, but in general, just looking at this, you should be able to tell that if I change the arrangement of these p's around, I would not get a different word if they were all together. Okay, so in class, tomorrow we'll be trying some different ones, but hopefully you were able to figure these out.